In section 7.5, we will explore quadratic inequalities. The first thing to look at here is interval notation. We want to remember that we use brackets when something is included, and we use parentheses when we do not want to include that particular value. So we've done this before, and so what we want to do is remember the notation for each of the examples below. I'll walk through the first one. For number 1, we would want to think about what this would look like on the number line. So on the number line, I would have an open circle at 5. And my arrow, because this is saying that it's greater than, my arrow is going to point towards the right. It's all the numbers that are bigger than 5. Now from here, when I go to actually write my interval, as I scan this from left to right, the first time something is actually graphed on the left side here is at this particular value, which we said is 5. And because this is an open circle, it is not included here, and that's why that's going to get a parenthesis. Then it goes all the way over here to this arrow, which is pointing towards positive infinity. And we want to remember that since it's not actually stopping at infinity, and we're not saying that infinity is included, we're always going to have a parenthesis, whether we're talking about positive or negative infinity. Next, I'll have you guys take a couple minutes to do 2 and 3. This would be a good time to pause the video. And here's the answer to number 2. If I again create that number line and I place 9 on there, this is going to be a closed circle, and that's because we have the equal sign here. Then, since this is talking about all values that are less than or equal to 9, I'm going to want to make the arrow going to the left. And here, as I'm looking from left to right, the first time something is graphed is here is that arrow, and that arrow is pointing towards negative infinity. Again, that would have parentheses by it. It ends here at this closed circle, and that's at 9. And that's going to get a bracket, again, because it's actually included in the interval. And then finally for number 3, here I have 2 values that I have to place. At -2, this one is not going to be filled in. It does not have the equal sign. And at 6, it would be a filled in circle. Then from there, the part that's going to be shaded, or the line that we're going to connect, would be between these two, because we're saying that x is greater than, bigger than -2, and it's smaller than 6. So it's going to give me this space in between here. When I go to write this out, the interval, the first time anything is graphed, is here at this open circle, which is at -2. Again, it's not included, so it's going to get a parenthesis. And then that goes up to 6, which is going to be included. So that should be our final answer for 3. Now here we're going to be given the graphs, and we want to come up with the interval notation. So take a couple minutes to pause the video and try these 2 examples. Now with example 4, again, I'm looking when's the first time something is graphed, and as I'm going left to right, the first time something is graphed is at -3, and that's included, so it's going to get a bracket. Then it goes all the way up to +3, which is not included, meaning it's going to get a parenthesis. So that is going to be the interval notation for that graph. For 5, the first time something is graphed is at -infinity, because that's where this arrow is pointing, and that goes up to +2. So I'm going to have -infinity up to 2. Then over here, this one is included, which is why I need a bracket, and it starts at 7 and it ends at +infinity. And again, infinity is going to get a parenthesis. Now as we start looking at quadratic inequalities, we're going to need to find what's called the critical values. And to find the critical values, we're going to factor. So as long as this is set up where it's in standard form on the left side here, we can go ahead and factor this. If I did have any numbers on the right side here, or variables, I would need to move those over first. Now from here, when I go to factor this, I'm going to end up getting the quantity x minus 5 times the quantity x plus 1. I'm going to set each of those factors equal to 0, and I find out that my critical values are at 5 and -1. Now I'm going to want to place those on my number line. And as I'm doing that, I'm trying to decide if these are going to be open or closed circles. Because this says greater than or equal to 0, these are going to both be closed circles. So I'll put those at -1 and positive 5. Now from here, what we're going to need to do is test each of these regions, and we want to see where are they true and where are they false. So I'm going to start out with what I think is the easiest value to test, and that's 0. 0 falls between -1 and 5, so it's in this section right here. When I go to test 0, what I'm doing is I'm plugging it in for both of these x's. Now that's going to end up giving me -5 is greater than or equal to 0, and that is false because I can say -5 is not greater than, it should say, or equal to 0. So that's false. That means that this section right here will not be connected. So then I'm going to look at the outer parts. So if I start with, and I can pick any value I want over here. I could pick -2, -3, -4. Here I picked -5. Now I would take -5 and I would plug it in for both of these x's. -5 squared is going to be positive 25. -4 times -5 is positive 20. So far I'm at 45 minus 5, which is 40. So I would say 40 is greater than or equal to 0. So that means that this side is true. So I can go ahead and put an arrow on that side. Then I'll go ahead and test the right side. And here I've chosen to use a value at 6. But again, I could use something like 10. Anything that's bigger than 5 would work here. So when I use 6, I've got 6 squared, which is 36, minus 4 times 6 is 24, and then minus 5. That ends up giving me 7, and we're testing, is 7 greater than or equal to 0? Yes, therefore it's true, and that means that that part's going to get shaded. Now, one thing I want to mention right now is that when you read this statement, if you think of this as great or, then you would hopefully realize that this is an or problem, that the two sides are going to point in opposite directions. So we're going to kind of look for that pattern to continue happening throughout our problems today. Finally, when we go to write the answer, we're going to write this in interval notation. So we're going to start at negative infinity, go up to -1, and that'll have a bracket. Then we'll start at 5 and go to positive infinity. And this would be our answer right here. Again, both -1 and 5 have the brackets, and then the negative infinity and positive infinity values are going to have parentheses. So this would be a good time to pause the video and go ahead and try both question number 1 and question number 2. For number 1, when I factor that, I'm getting x plus 10 times x plus 2. If I set each of those equal to 0, I find out that my critical values are at -10 and -2. So again, if I plot those accordingly, this time they're both open circles because it doesn't have an equal sign here. So from here, again, I need to test my different regions. So if I start with the middle section here, I picked -5, but again, you could test -3, -4, -5, -6, anything between these two values, but not including those values. So if I plug that in here, I've got -5 squared, which is 25, minus 60 plus 20. That is going to give me -15. So my statement would read then, -15 is greater than 0, and that is false, which means I'm not going to be able to shade or connect that section. From there then, if I look at the outer two regions, over here, this is probably the easiest value to plug in at 0. And again, I could have picked -1, 0, 1, anything over here, but I'm going to try to pick the easiest ones that I can think of. This is just going to say 0, this is going to be 0, and this is going to be 20. So we're thinking, is 20 greater than 0? It is, which means that that part needs to get shaded or graphed. On the other side, I could try -11, -12, anything over here. I chose -11. When you plug in -11 for both of those x's there, your result should be 9. And so we're saying, is 9 greater than 0? It is, so we can say that this is going to have to get an arrow as well. So now when I write this final answer, again, it starts at -infinity, goes up to -10, then it starts at -2 and goes up to positive infinity. Everything here has parentheses because, of course, always the -infinity and positive infinity do, and then when we're looking at -10 and -2, those are not included values, so those will get parentheses. Now for number 2, again, I'm going to find the critical values right away by factoring and setting each factor equal to 0. Then I'll place those on my number line. From there, again, I want to make sure that they are in order from smallest to biggest. And then I want to keep in mind that because I've got this equal sign here, that's why these are both going to be filled in circles. Now again, from here, I want to look at the test regions. The first one I'm going to look at is between these values. So at -2, if I plug this in here, I've got +4, -10, +4. That's going to give me -2. And so then I'm thinking, is -2 less than or equal to 0? And it is. So since that's true, that part is going to get graphed. And we can just say that this starts at -4, goes to -1, and because those values are included, they are going to be closed circles, therefore brackets. Now, I mentioned when we did the example a few minutes ago that if it was a great or then problem, I was expecting the arrows to go on the outsides. So this is another example of that. This says greater, but you want to think about it as great or, and it makes it an or problem. It's either this side or it's this side. This one I think of as less than, and is when they're connected. So that's just a little bit of a clue to how they will look before you even start testing your points. Okay, before you start to work on 3 and 4, one thing I want to mention, on number 3, there is an issue with this one. I do want you to change that last addition sign to subtraction, and that will make this problem work out. So what I'd like you to do right now is go ahead and pause the video, try both 3 and 4, and see if you can come up with the critical values and then the final solution. So on number 3, we can go ahead and factor since we changed that to subtraction at the end, and our factors are x plus 3 and x minus 4. From there, if I set both of those equal to 0, I'm going to get -3 and 4 as my critical values. Now if I put those two on the number line, again, they're going to be filled in circles because we've got the equal sign here. And then from there, when I start to test things, I generally will start in the middle. Now again, we kind of want to start to think about, this says less than, and it's an and problem. Therefore, I'm expecting that this is going to get connected and that my solution will start at -3 and end at 4, but we're going to do a test point for that. So I pick a number that's easy to plug in between these two, which in this case, I would say the easiest thing is 0. When I plug 0 in, again, this is 0, this is 0, so I'm really just left with -12. Then I'm saying, is -12 less than or equal to 0? Is it true? It is, so that means that that part should be graphed. So I can go ahead and connect that. And again, I'm done at that point. So the solution is going to start at -3, end at 4, and they're both brackets because they're both included values. Then for number 4, again, I'll factor. When I factor and set each factor equal to 0, I find out that my solutions are -1 and 9. I'll go ahead and put those on the number line. And again, this time they're both open circles because we don't have the equal sign here. From there, when I go to test my different values here, again, if I start in the middle, I might start at 0, which is here. So when I test 0, I've got 0, -0, -9. So really just -9 is greater than 0, and that is false. -9 is not greater than 0. So that means that this middle section should not get connected. And again, if we're thinking about the fact, and this only works as long as the variable is on the left, but this says great or, and the great or, it's either this or it's this. So from here, when I go to write my solution set, again, from the left to the right, the first time we see anything is this arrow that's at -infinity up to -1. Both are going to be in parentheses. Then I start at 9 and I go up to +infinity. And by the way, this value should have been a 9 in this example. Now we're looking at Part C, quadratic inequalities. With these graphs, we're looking at where are our x values less than or equal to 0. So as I look here, I can see that tracing this, here is where our f of x values are less than or equal to 0, in this section right here. It's also in this section right here. So in terms of writing my answer here, I have to say that it's all on the outside up until I get to -1, and then it starts again at 5, and it's until +infinity, where they would be less than or equal to 0. Now on number 2, the question's a little different. This says, when are they greater than 0? So greater than 0 meaning above the x-axis and not including the x-axis. So that's going to start at -8, but -8 is not going to be included. It's going to go all the way up to -4, which again will not be included. So that would be my answer on number 2, -8, -4, both of them being parentheses because again, they're not included. So now we will focus on graphing quadratic inequalities. When we do that, the process is very similar to what we did with section 7.4 with just graphing quadratic equations. So first we'll start by finding our zeros. Our zeros can be found by factoring. Now our first step here would be to add this 5 over, and that gives me this right here. Now from here, in terms of factoring, I'm going to start with a GCF. I take a -1 out. From there, once I take that -1 out, I'm left with x squared plus 4x minus 5. Once I have that trinomial, I can go ahead and factor further. That gives me x minus 1 and x plus 5, which if I set each of those equal to 0, that's going to give me 1 and -5 as my two zeros. And I'll be putting that in the chart and graphing that shortly. The next thing we could look at is the axis of symmetry. And to find that, we're going to do the opposite of b. So keep in mind that this is again b, that -4, divided by 2 times a. So that's going to give me +4 divided by 2 times -1, which makes this x equal to -2. So I can plot that, and then I can use that to start finding the vertex. When I go to find the vertex then, if I take that -2 and plug it in for both of these x's, that's going to give me +9. So now I can plot -2, 9, and I want to kind of get an idea of what this is going to look like when I'm graphing it. We knew all along that it was going to point down because it's got that negative value for a, that negative lead coefficient, and from here I know that it's going to cross at +1 and -5 on my x-axis. So I can go ahead and plot those. Then I'll want to do one more value in between here and between here. And ideally, they should be equally distanced apart from the axis of symmetry. So I've chosen -4 and +0. When I plug each of those in, they're going to both give me 5. So I can go ahead and plot -4, 5 and 0, 5, and then connect those. Now the part that's new here is the actual shading. Because this says less than or equal to, the equal to makes this a solid line. The less than part is going to tell me to shade everywhere below the line. So that means that this inside is going to get shaded. And you really don't want to think about it as inside or outside initially. You want to think above or below. So if it was above, it would end up all outside in this situation. And if it's below, it ended up all inside in this situation. So this would be a good time to pause the video and try number 2. Now for number 2, we want to start by solving for y. Once again, I add the 15 over. I've got x squared plus 8x plus 15. From there, I'll go ahead and factor that, which gives me x plus 3 times x plus 5. Set each factor equal to 0, and I'm going to get solutions of -3 and -5. We'll come back to that part in a minute. Next, if I look at the axis of symmetry, it's the opposite of b, so -8 divided by 2 times 1. That's going to give me -4. So I can plot that and use that to figure out my vertex. Now if I plug -4 back in for both of these x's here, I end up getting -1. So that's going to be my vertex at -4, -1. From there again, I can plot -3 and -5. And if I tried to find 2 more values, such as I could use -6 and -2, you could use different values here, but those are the 2 that I chose. I ended up getting 3 as both of their output values, or in this case, their y values. So I can plot those, go ahead and connect that. And then again, now I have to look at where is the shading going to be. So because this says less than or equal to, it's everywhere below this parabola, and that's going to actually put it on the outside here. So your shading should look like this for number 2. Now we take a look at number 3. Here we're given the graph and we want to figure out which one it's going to match up with. So the first thing that I would be looking at here is this a greater than or equal to or a less than or equal to sign. So take a minute to see which one you think it is, if it should be greater than or equal to or less than or equal to, and cross off the ones that would not be options then. Now, this is an example of greater than or equal to because everything is shaded above our graph here. So that tells me right away it can't be the two that are on the left because both of those say less than or equal to. Now, if I compare the two that are left right now, I want to look for what's different about them. So this is the same, the same, the same, the same. The only thing that's different here is our value for B. Now, we know that that helps us to figure out what our axis of symmetry is. And I can tell in this graph right here that my axis of symmetry would be at +5. So I want to look at the axis of symmetry for each of these examples and see which one would have an axis of symmetry at +5. If I do that with the top one, I get the opposite of -10 is 10 divided by 2 times -1. That gives me -5. And that does not match up with the axis of symmetry here, so it's going to have me eliminating that one. And I'm hoping that this last one works, and it does because here if I do the opposite of +10, it's -10, divided by 2 times -1, it gives me +5, so that would be the correct answer. Pause the video and try the same thing for number 4. Now again on this one, this is an example of less than or equal to because the shading is happening below the graph. So with that in mind, I'm going to be able to cross off the top two here. Then again, I want to look for what is different about these. And again, the part that's different is the value for B. We can see that this axis of symmetry would be at -3. That's what would cut our parabola in half and make it equal on both sides. So from here, if I tried to find my axis of symmetry on this one, it would be -6 divided by 2 times -1, which is +3. So it doesn't match up with that answer. The other one is going to be +6 divided by 2 times -1, which does give me -3. And since that's what I'm looking for, that is the answer. Do the same thing for number 5. Go ahead and pause the video and see if you can eliminate the answers until you get the correct solution. And here again, I'm looking for, is it greater than or equal to or less than or equal to? This one is definitely less than or equal to because it's all shaded below this parabola. So from there, I'd be able to eliminate the top two. Next, what I'd be looking at is, again, my axis of symmetry. It's at +6. So if I look at it for this one, I've got -12 divided by 2 times 1. That gives me -6, so it cannot be that one. With the other one, I've got +12 divided by 2 times 1, and that is going to give me +6. So that makes that one the final answer. So now please complete the associated Delta Math assignment for section 7.5.